Hi, everyone. My name is Filipe Garbim, and I'm glad to be here and glad to have all of you here as well. Today, we're going to talk a little bit about Sensedia API Gateway and Sensedia Service Mesh and how both tools can work together in order to give you a centralized way to monitor your APIs and to manage better the traffic of your services, and also how to create standard security for all your services that are running inside your internal infrastructure. Okay, so let me just share my screen here. So presenting myself, I'm Filipe Garbim. I'm a solutions architect here at Sensedia, and here it is, my QR code. Okay, so please, if you want to take a picture of it, and then you can contact me on social media. We can talk a little bit about microservices, service mesh, APIs, event-driven architecture, governance, and so on and so forth. So please contact me. It will be a pleasure to talk to you. Okay. So let's start a little bit about our agenda. So first of all, we're gonna see what are the most common challenges of a microservices architecture. Okay, so this is the first thing that we're gonna talk about. The second thing is how we can accelerate the overcoming of those challenges using service mesh. So where service mesh really stands when we're talking about those issues. After that, we are gonna see how service mesh and API gateway work together. Okay, and finally, last but not least, the demo. Actually, this is the most interesting part, right? So we're gonna see how both tools can increase the level of observability of your ecosystem. Okay, when we're talking about microservices and APIs. So starting here, what are the main issues when we are talking about microservices? So with the explosion of microservices, things started to get complex, started to be more difficult to manage and address in a distributed environment. So those are the four main issues when you are adopting a microservices architecture. First of all, the first one is standard security implementation. So many companies have multiple environments, multiple services, multiple teams. So it's hard to standardize the security. So imagine that you have a lot of teams working and developing microservices, and then each team are thinking about how to apply a specific kind of security for their microservices. And imagine that your developer has to think about how to develop a microservices in terms of business, and also about non-functional requirements. So it's kind of hard to deal with it, and sometimes you don't have a standard security. Well, most of the times you don't have a standard security. So this is the first main issue. The second one is traffic management. So most of the companies today are API based, which implies different types of deployment models. Internal deployments, external deployments. I have to expose my APIs, and imagine that I have version 1 and version 1 of my microservices running inside my Kubernetes cluster, for example, and I have to release version 2. So what I have to do, I have to think about, my developer has to think about how to route and deploy the version 2 and how to route the requests to version 2. So, and there are a lot of strategies to do that. So it's kind of hard to think about it, and it's hard to apply it. So Service Mesh can help you with that. So this is the second point. Traffic management is an issue. Third one, lack of observability. So this is a very common issue when it comes to observing north-south, and east-west traffic. Some companies don't do this yet, so they don't have They don't know what's going on with their microservices or their APIs. And some companies don't do this yet in a centralized way. Some companies, they do have monitoring tools, but they are far from each other, and then you have to navigate in many tools to understand what's happening with their microservices. So you don't have a centralized way to observe all your ecosystems or your clusters, okay? So the fourth issue is service discoverability. So what are the microservices that are running inside my ecosystem? How many microservices do I have? I imagine that I have hundreds of microservices. How can I manage them? How do I know where is the problem? How do I know if they are healthy or not? So this is another main issue that we have, okay? So basically, we can solve those issues using API platform, which you can see north and south communication, and service mesh, which helps you with the east and west communication. So basically, this is the demo scenario, which we have two different networks here. Network A, which is the API platform itself. It's running a SaaS environment, it's running in the cloud. And then you have a network B, which is your mesh infrastructure or your Kubernetes cluster running inside your infrastructure. And then, as you can see, there are many benefits when it comes to service mesh, because you can standardize your security, you can manage your traffic, you can observe all your microservices, and also you can abstract the complexity of issue, for example. So you don't need to give your developer the responsibility or the role to think about your infra problems. You need your developer to focus on the business development of your microservice. So these are some benefits of using a service mesh strategy. Okay, so basically that's what we are going to see, how you can benefit from using API platform and service mesh. Okay. This is a quick overview of our product, our Sensedia Service Mesh. So basically, there are a Kubernetes layer, and you have Istio running inside your Kubernetes cluster there. And Istio is resolving all your network issues, your network management. And then you have Sensedia Service Mesh on top of it. So basically, we use Istio APIs or Istio interfaces to create a product which will help you manage all those non-functional requirements: traffic management, security, observability. So Sensedia Service Mesh abstracts Istio complexity and then gives you a centralized way to do all of those things that I just said. Okay? So this is the demo use case. Basically, we have here our Kubernetes cluster running 3 different services: account service, payment service, and customer service. As you can see, account service is being exposed to the external world via the API platform and the API gateway. And the account services is routing the requests to the other 2 services, the payment and the customer service. Okay, those services are being managed by Istio, and our product is on top of it. Okay, so before we start, guys, I would like to give you an overview or give you a context of what we have here. Okay, so just a second. So I'm gonna show you guys the Kubernetes artifacts that we have in this in our demo cluster here. Okay, so what I'm doing, I'm going to get the namespaces. So as you can see, using a kubectl command here, I'm using an alias here, which is K. Okay, so we have a bunch of namespace here, and as you can see, there is, all of them are active, and we are going to use this one, Sensedia Bank, okay? So keep that in mind, and we will get there. So what are the pods that are running inside this namespace? Let's see it. We got pods, namespace Sensedia Bank, and as you can see, there are the three services are here, okay? The account service, it has 2 pods running inside the cluster, okay? We have the customer service with 2 pods as well, and we have a payment service which has 3 pods running here, okay? But there is one interesting thing here. See, there is a payment service v2 here as well. So later on, I'm going to show you how we can route the request to version 2. One important thing here to mention is that, as you can see, there are 2 containers for each pod. Why is that? Because of the invoice sidecar proxy, okay? So we have the container running my microservice, and we have also the invoice proxy sidecar running behind it, okay? Or which is receiving all the requests, okay? Great. So let's go to the user interface. I'm going to show you. This is the mesh, the Sensedia Service Mesh interface. I'm going to sign in with OpenID, okay? As I have already signed it in before. Here it is, my name. And those are the meshes, okay? What are meshes for us? Basically the namespace that the Kubernetes is managing, okay? So if I want to enable a mesh here in Sensedia Service Mesh, I need to enable issue injection, okay, of the sidecar for the namespace. So as you can see, Sensedia Bank is here, and this mesh is healthy. There are 8 pods here, which is provisioned, okay? So what I'm going to do is I'm going to edit this mesh here. And there are a few data here, okay? A brief description of the mesh, Sensedia Bank. And this is very, very important, guys. This is the host. Or what is it? What is it? Basically, this is how you access the services inside the cluster, okay? Through an external host. So we are using a load balancer host here running on AWS, okay? So every time you need to call this service or the services that are running inside this namespace, you have to send a header host with this host here, okay? There is also the TLS configuration here. So I have a TLS enabled for my ingress controller. So this is very important because I'm enabling HTTPS for the calls of the API, okay? I have also the credential name here, which is a secret, and all the certificates in order to give more security for my services. And this is very important because not only when we are talking, there is no we are talking about TLS, not only when we are talking about north and south communication, but east and west communication as well. When you have to service communicate, when we are talking about service-to-service communication, okay? Great. What else do we have here? So I'm going to open this mesh here, Sensedia Bank. And as you can see, my services are discovered as already. Okay, so I have the account service, the customer service, and the payment service. Important to mention that the account service is routing the requests for the other 2 services, the customer and the payment. So those are healthy. We can see the pod quantity here. And also, this is very important because we can see the first observability feature of the platform. I can see that this microservice here that is running inside my cluster is exposing an API to the API gateway. So there is a connected API here. If I click here, account service is stable. I'll just let me, I was not logged in. Just a second, guys. All right, so if I click here, account service is stable, you see that this is the API platform or the API manager. And this is the API that is exposing my microservices to the external world. So I have a few basic information here, the base path of the API, where is it running, a brief description of the API, what is the type of the API, and so on and so forth. You can see that where the API is deployed, so it is deployed into the development environment. I can see the resources of the API, accounts, balances, accounts by account ID, and account statements. So this is very important because now I know what is the API that I am exposing to the external world, okay? And as you can see, the other services are not exposing an external API, okay? So what else do we have here? We can configure an authentication into the mesh context. So if I configure an authentication here, all the services will apply this authentication, okay? Okay. I think there is nothing else here to show. What I'm going to do now is I'm going into deep dive into this account service here. So I'll click it, and now I can see the pods that are being managed by Kubernetes. So I have 2 pods here. I have the sources. Just let me run it. I forgot to run. So basically, I can see the source. We don't have it yet because there is no load here for the microservices. So I will be back in a minute. This is the metrics as well. So soon you see that all the traffic that is happening here in my cluster, you see here. So we will see the request volume. We will see request duration in milliseconds. So you can see that the graph is already moving. We can see the request size in bytes, and we can also see the response size in bytes, okay? Okay, let me come back here. So this is the source. This is very important because now I know who is calling my API or my microservice that is running here. So basically, this account service is being exposed to the outside world, and how is it done? It is done by an ingress gateway or an ingress controller. So that's how we know it. If I come back here into the mesh and I select another service, for example, customer service, and I'll go to source tab, you see that who is calling this service? Account service is calling it. So now you know you have all the visibility of the microservices, okay? So let me come back to the account service here. I can also manage the traffic and also the authentication. We will see later on this little guy here. So let's talk a little bit about the traffic management. So what we have here is we have 2 different rules already created, okay? So we have an external one and an internal one. If I click here and edit this rule, you see that it is a release. This service is being exposed through the port 5000. You can see that it is an external connection type because I'm exposing the API, the service to the external world. And also you can see that there is an API metadata here. So I'll give it a name and the URI of the API that is located on the API platform. And what about the destination? So basically all the requests that I will receive or this account service will receive will route to the version 1 of the service, okay? So this is one kind of release that we have. We do have as well the internal one. So if I want to expose my service even to the internal world or service-to-service communication, I can do that, but I have to create a rule for that. So I have to create an internal connection type, which will receive as /accounts in the path and the destination, okay? So what else can I do here? I can use or I can create a Canary release, for example. So imagine that if you know Istio, you know that it is hard to create YAML files, and it's tough to create YAML files. So this is an easy way to create YAML files or Canary release. So what I'm doing here is I'm going. Sorry, not the account service. I missed the service. Actually, what I'm going to do is, before we create the Canary release, I want to show you one thing very interesting here, which is the graph. Okay. So what can I see in this graph feature? Basically, I can see what is happening in my cluster. Zoom out. So what we have here, we have the ingress gateway receiving the requests. The account service is receiving it in version 1, and it is routing the requests to this customer service and to the payment service, both using version 1. And both the services are calling a service DB here. Okay. What else can I see here? I can see requests per second, for example. So I know what is happening in each leg of the communication. You can also see the request percentage. Okay. So I'm receiving 100% of the requests, but I'm splitting or spreading the load 50-50. Okay. So let's get back here in our mesh. What I'm going to do is I'm going to select the payment service. Why is that? Because the payment service has version 2. So let's go to the traffic management tab. I will create a new rule here, a Canary release, and I will give it a name. Payments version 2, port 5000. I can even enable MTLS if needed. What is the connection type? Internal. The path, which is payments. And I can split the load by weight and by header. So if I want to use header to route the request, I can use it. But for the sake of this demo, I'm going to use the weight option here. Okay. So what is going to be the destination of the load right now? So I will give it a name, again, v2. I can pick version 1 or version 2. I will pick version 2. And what is going to be the load? What is going to be the weight, actually? So 20%. If I save here, now you see that I have another rule here, which is an internal, and it's by weight. So if I come back to the graph, let me just... Okay, so what we are seeing right now, guys, now my payment service is routing the requests by weight. You just have to wait a little bit because it's an average, okay? So I'm sending the load here, and as you can see, I'm splitting the load between both services. So that's how easy it is to create a Canary release. You don't have to worry about YAML files or stuff, okay? So you can do this that way, okay? What else do we have here when it comes to observability? We have the tracing capability as well. So if I click tracing, I will select my Sensedia bank mesh. I will select a service which I want to trace, search. Here it is. All the requests that I have made are here. Okay, so this one here, which has two spans, the services account service and the payment service, and it took 36 milliseconds to complete the work. Okay, so as you can see here, there are two spans, one account service, one payment service, and you can see how long does it take to finish the work. Okay. So as you can see, guys, I'm showing you how you can observe your microservices inside your Kubernetes cluster using Istio, and our platform basically abstracts Istio complexity, and then you can see all together in one only user interface. Okay, so we are talking about east-west communication. What about the north and south? So let's get back to our mesh. I will select the Sensedia bank mesh. I will now click here to go to my API that is running in my API platform. So this API is exposed to the external world. Okay, so basically my partners, my clients, they can call the API right now. If I want now to see the trace of the API running in the API gateway, how can I do that? I just click here, trace API, and now I can see the trace of the API. Okay, so basically there are a few requests here, result 400. I can see the latency. If I want to see more details of the request, you see overview of basic information of the request, the URI that was called, the app, what is the status, and so on and so forth. The other tab is the gateway trace. So you can see that all the steps that were executed by the gateway, you can see it here. And you can also see how long does it take to complete. So for example, you can see that the gateway, it executed the API interceptors, the header, interceptor log, and you can also see a request log here. So imagine that I want to see what is the payload. I just click in this little guy, and then you see that there is the headers and also the body, okay? And I can also see the response log here. So it depends how you designed it or you implemented your API in your API gateway, okay? One important thing here is that this API called the microservices running, they're running in my Kubernetes cluster. So how long does it take? It took 474 milliseconds to complete, okay? So this is a very interesting view when it comes to observability, okay? What else? I can also see the dashboards of my APIs, my API gateway. So I will open my Kibana here. So all the metrics, all the trace are stored on Elasticsearch, and then you can see it on Kibana. So I have here a few views already configured. As you can see, total calls by status code. I can see what is happening to my APIs in a general view, or I can even filter if needed. So if I want to pick and see what is happening within a specific API, I can do that using the filters option here. Okay, what else do we have? We can see the top 10 latency by API, the total requests, percentage by status code, and so on. So you are free to create how many views you need, okay? And I can even pick here the time range if needed, okay? So this is a very interesting dashboard that gives you a more okay, so let's go to the next part here. So imagine that I don't have a team to be looking at my dashboards. So how can I react if there is something happening if something wrong is happening with my APIs? There is an add-on which calls flexible actions. When you click here, you can create runtime alerts. So basically, this feature are looking at your API's health, and then based on your alert definitions, it will send you an alert by mail, by Slack, or even you can use a webhook for that. So I do have here already an alert definition already created, which is account API error 400. If I click here, basically, If this API, accounts API, deployed at environment development, resource accounts, operation post accounts, returned more than 5 calls with 400 over the last minute, then I will receive an email or Slack or a webhook will be called. Okay, so as you can see, I have a receiver here, and I have also a workspace in Slack already configured. Let me show you guys one example of an alert. Here it is. Okay, as you can see, this is one example of an alert that you receive by email. So Sensedia flexible actions and the alert that something wrong is happening. Okay, and there are other things as well that you can configure. For example, if I want to add it to this event, I can use different kind of notification types. Okay, I can use, for example, latency, availability, total calls, so I can use different kind of notification types. Okay, so there is another view here that I wanted to show you guys is the impact analysis. So when we're talking about observe the APIs and governance, how can I plug the API and the microservices together? So I will select the Counts API here. It is the one that we are using. The environment that it is deployed, I will search. And now you see that we have a view of a map of dependencies of the API. So basically, you have the API here. You have basic information of the API, the base path, the name, how many calls it received. And also we can see what are the resources. So there are 4 resources here of the API. There are 5 operations, and you can see the destination of each operation, okay? So, and these API destinations are the microservices that are running inside my Kubernetes cluster that is being managed by our Sensedia service mesh, okay? And another interesting thing here is that I can see who is calling the API. So who are the partners or who are the clients or the apps that are calling the API. So basically I can see that there is only one app, the partner app, that is calling this API through a plan or a gold plan, okay? So imagine that you are running version 1 and then you're gonna move or change to version 2, and then you need to warn your clients or warn your partners that you're going to retire your APIs from production. So how you can see this? How do you know what are the apps that are consuming your APIs? Basically using this graph here or this diagram. Okay. So guys, I showed you observability, east to west, and now I'm showing you how you can do this in a north and south perspective. Great. Now what I'm going to show you is a little bit about the security, okay? So let me pick here Sensedia Bank Mesh. And how do I apply an authentication, for example, to a specific service inside my cluster? How can I do that? So I will select the payment service. I will go to the authentication tab. And as you can see, there is no authentication configured here. So if I go to the Postman here and I pick the payments service operation and I'll send it, you see that it's okay. I have a 200 status code. Now, if I want to apply an authentication, I can do in 2 ways, basically. I can click here, configure authentication, and then I can add information here using the user interface. But I can also use Kubernetes commands, for example. So this is very important because I don't have to use a user interface. I can use a CLI, for example. As our service mesh is Kubernetes native, I can do that. So basically what we are seeing here, everything that I did, remember the Canary release, the stable release, they are all YAML files. So as you can see, there is an account Canary here, YAML here, and all the information that I did. So as you can see, weight 20. I have also the account internal, and I do have as well the payments of the YAML file here. So as you can see, guys, there are a lot of informations here. For the sake of the demo, I'm using a Keycloak. I'm using Keycloak inside the cluster. So there are a few informations here from the Keycloak, for example, the issue and then the JWKS URI as well, as I am using OpenID Connect, okay? So how do I apply this security to my mesh? So basically, I will apply using the kubectl apply -f -payments of is the YAML file that I want to apply. And what is the namespace that I'm going to apply? Sensedia Bank. So when I do that, just 2 seconds, and then you see that, okay, the policy is created. Now, if I refresh here, user interface, and go again to the authentication tab, the policy is created, okay? As you can see, payments authentication, the status is provisioned. And if I edit this policy here, you see that all the information that it is in the YAML file, it is here right now. If I do the opposite, if I insert the information here and update or create, the YAML file is created, okay? So what we have here, we have an important field, which is the included path. So every service that needs to call this, the service, the authentication is applied when you are calling a /payments service, okay? So let's do it. I will come back to the Postman, and now I will send a request using the same request here. So I will send it. Okay, here it is. There we go. 403 forbidden. So you don't have access to this service, to this payment service. So how can I be able to call it? So I will have to get a token. So I will get this Keycloak service here. I will send it. I will get the access token, which Keycloak provided me. Now I will add our authorization header, and I will send it as a bear token. Okay? If I send it, here it is. Now I am authenticated to call this service. So, guys, basically, that's it. That's what I have to show you. That's the workshop. So, in short, how Sensedia Mesh can help you. It gives you a centralized way to observe your microservices. It is easy to create policies in order to manage your traffic, manage traffic of your services. That's how you see what's going on with your microservices ecosystem. And also you can remove the responsibility of your developer to think and apply non-functional requirements to the microservices. You leave this responsibility to your operations team, okay? So imagine that you have hundreds of microservices. It is easier if you use a service mesh, okay? Using, obviously, an API platform in order to have this observability north and south as well. So guys, that's it. Let me see if there is any questions here. Please feel free to ask, or if you have any questions, I'll be here to help you out. So if you want to, again, take a picture of my QR code, please feel free. You can contact me on social media, on LinkedIn. We can talk a little bit more about what we talked today in this workshop and other subjects as well. I will be glad to help you, and Sensedia as well. Okay? So if there are any questions, that's all, folks. Thank you very much for your attention, and I hope to see you soon.